All right, this is our second episode of our group learning tech stuff. And I will start with my demos. And to make things a little more visible, I will sort of minimize the window up there. Okay, so the first demo that I wanted to show is this very cool library called Capstone. So all this really simple demo is about is that I have these sets of hexadecimal numbers, right? And so what these hexadecimal numbers actually are the encoding of assembly instructions, right? So assembly instructions in hexadecimal formats. So for those who are into sort of cyberCTF competitions and doing the binary challenges, right? In a lot of them, you're going to have to write shellcode. So you're going to have to get really comfortable with encoding, writing shellcode in hexadecimal. So that's what this hexadecimal string is. It's sort of the representation of assembly code in hexadecimal. So all this library is it's a disassembly library. And what I'm doing here is at first, right, I'm creating this object, this capstone object. And then after I create that, let's see, okay, so that creates that. And then that's going to be in this MD variable. And then in the MD variable, I'm going to disassemble. And what I'm going to disassemble is that code, right? So this code string right here. And in this case, I'm disassembling it as x86 instructions. So this just loops through all that code, and then it disassembles it, and then it prints out first the address, which we specify starts at 1000 hexadecimal, the mnemonic, so the actual instructions, and then the operations for the assembly instructions. So let's run it and see what happens, right? So the name of that file is Control-G, test1. So Python test1, here we go. And this is what this is. And so to validate that, what I like to do is I'm going to use this website right here that does online disassembly. So, and that's, okay, let's move this one over. So if we look at the code, right, that's the, let me try to resize just right. See, that's the exact same code. And if you disassemble it for x86, let's disassemble it, right? These are the instructions: push, deck, move, deck, and add. And oops, okay, so that was 64. Let's try. Okay, so since we're in 64, so this is the disassembly of the 64. Let's see what it looks like on the website disassembly for ground truth here. Okay, there we go, disassemble. Okay, that's disassemble as 64, and then we get these instructions right here: push, RBP, move, and add. And if we go back to our script running, right, it's the exact same instruction. So, you know, the disassembly worked. And the other thing that I wanted to point out for people that are new to assembly language, right? So, you know, this was our original hexadecimal string, right? So the way the disassembler works is that it will interpret each of these as a specific opcode depending on the assembly language. So for x64 here, Intel x64 or AMD 64 here, right, 55, that's the opcode for push RBP. And this long string here is the opcode for a move this value to RAX and etc. So that was the 64-bit disassembly. So the next thing I wanted to show though was instead of 64, right, we have the same code string here, but let's change it to 32 bits instead, right? So we do 32-bit, okay? So this is what this value of hexadecimal, when you interpret it as x86, right? This is what the instructions will be in x86. And let's verify that really quickly on our website here. Disassemble. And yeah, push, deck, move, deck, add. We look right here, push, deck, move, deck, add, right? So that is in a nutshell how Capstone works. The other libraries that are very closely associated with Capstone, I believe, are keystone and I think a unicorn. So the other one I think is an assembler, and then I think the other one is a CPU emulator. So, this demo, right, and I think the code I got right here is directly from the example from the Capstone GitHub. So even though the example I showed here is very simplistic, in future iterations of our working group, I will hopefully show how we could build upon this to solve very interesting CTF challenges, right? And sort of what the powerful capabilities Capstone can give us. So that was my Capstone demo. The next demo I'm going to show is the Z3 solver. So example Z. So Z3, right? So what is Z3? Z3 is a theorem solver. So it's more precisely, it's an SMT. It's an SMT solver. And let me pull up some websites here that hopefully can give you a little bit more context, right? So as I was saying, geez, man, this is bugging. Okay, right here. So it's an SMT solver. So basically what SMT and then SMT builds on SAT, Boolean satisfiability problems. So what it is you have a set of different formulas, or I like to call them a bunch of equations, and you give it a bunch of these equations in the notation. I think it's called SMT lib notations. And if you get them these sets of equations, the solver has a set of heuristics and algorithms to solve those equations for you, and basically say, you have this equation here, 3x plus 2y minus z is greater than equal to 4. It will solve these values of x, y, z that will make this equation true. So that's what it is in a nutshell. So let's see it in action, right? So here, and there could be a little bit of group participation here because it's pretty straightforward, right? So say I have this simple equation here, right? X plus y is equal to 5. So I need two variables that equal to 5, and x is equal to 2, and y has to be greater than 1. But really, you could just focus on these first two equations, right? So if x and y has to equal to 5 and x is equal to 2, what will be the value of y?
I think y would be 3.
Exactly, y would be 3, right? So Z3 will be able to solve that for us, is sort of, that's the power of Z3 here, right? So basically, the challenge though is to represent the equation in the actual programming language. And here I'm scripting it in Python, and I'm porting the Z3 library. So I create these real variables. Then I create this solver object. I add the equations, and then I ask it to check if it's solvable, and then I will print the model. So the model is the actual solution to the solved equations, right? So I run it, and here it is, right? It's satisfiable, and this is the model for a successful solve. So y is equal to 3. So this right here is a very simple example, but the reason I'm showing this is that it is very powerful for the crack me types and some of the hashing types of challenges for CTF competitions. Excuse me, where in the assembly, you have a bunch of these very tedious, complex equations that if you have to do it manually by hand, it's extremely challenging and time consuming. But if you model it with Z3 can trivially solve it for you. So here I guess sort of give you another example that is sort of a little more complex, right? So now I have two variables that add up to 7, and both one has to be greater than 1 and the other one has to be greater than 2. And this is just a artifact from my previous testing. But say that that's the case, what will be the solution? So in this case, it came up with y is 5 and x is 2. So really simple examples, but I believe this is just sort of the foundations of the functionality of these libraries, but in the future, I'm hoping to show how powerful these libraries can be. And the other reasons I shared, these two very simple examples is to make it clear to our group that examples of any skill level is welcome and appreciated as long as you think it's cool. Please share. Nothing is too simple or too noob, right? Everything is cool for us to demo. So those were my first two demos. And now I wanted to share my last demo. And let me really quickly pull up the reference for it. So I'm going to be going over, what a drag. Okay, I'm gonna go over this blog post right here by Enigma, Matt Nelson, lateral movement using DCOM, and specifically this object right here, MMC20. So that's what this is gonna be about. And let me pull that to the side here. So, okay, lateral movement. So first off, lateral movement for red teaming and pen testing purposes, right, is the ability to move from one machine to another machine. And in this case, right, we're talking about one Windows machine to another Windows machine through the DCOM interface, or do the DCOM subsystem. So, first, so you're gonna have to know what COM is and what DCOM is. So COM, the component object model, I believe, in the Windows system, that is sort of this very powerful object model that Windows has to share different objects and methods for these objects. And building off of that is DCOM, which is distributed COM, right? So that way you can share objects over the internet among many different types of systems. So that's DCOM in a nutshell. And I believe it runs over Windows, Microsoft RPC, the remote procedural call mechanism. And I believe that's port 135. So, okay, so that's DCOM and that's RPC, right? And so now I wanted to, so according to the blog post that I got this information from, right? What they're doing here is that what they found out was like there was this object, specifically the MMC, that's the Microsoft Management Console. Within that object, there are functionality that allows them to spawn other applications. So that's the mechanisms that they wanted to use to spawn another application on another machine that would then talk back to their original system. So that was the original idea behind that specific lateral movement technique, right? So, what is MMC? So let me pull up what MMC is. That is the Microsoft Management Console. So that's what this guy is right here. And what this console is, it allows you to add a bunch of these other functionality here. So let me say, I want to do device manager here. I could add it my local computer, okay. And then once I add it, then I have access to it in this MMC. And then I have access to all these different functionalities, right, that the device manager would give. So that's MMC. So now let's see how we can play with it within PowerShell. And that's what the blog post shares, is how do you go about manipulating it through PowerShell. So for those who are not familiar with PowerShell, I'm going to first run this command right here. So first I create a variable. So in this case, I'm creating this COM variable. And then I am calling a specific class. In this case, I'm calling the activator class here. Activator, and I'm going to tell activator to create me an instance of the class type here. And we're going to get type from prog ID MMC20 applications. And we're going to get that from our local machine here for now. 001, close parentheses, close parentheses. Okay, was that good? So let's see our handle. Cool. So we have it, right? So we have this object to this MMC application, this DCOM from our local machine. That's what this object right here in my COM variable is. So let's do more interesting. So let's see what kind of member methods are in it, right? So I can pass it, I can pipe it to the get member function within PowerShell, and it tells me these are all the different methods and properties that this object has. So what I'm curious in seeing is this com.document. So the document and then the active view. So I want to see from active view what kind of member functions I have. And a lot of good stuff here, right? But what I'm really interested in here is this execute shell command, right? Very cool, very powerful. This is what I'm going to want to call from my DCOM object .document.activeView. So let's try to pop a calculator with that particular method here. So what is the application? Okay, there it is. There's the syntax. Okay, so we go active view here. Then we go execute shell command C Windows system 32 calc.exe. And then what else do I need here? Then the other arguments, which is null. And according to the blog I'm sort of following here, they put the 7 for this last argument. And okay, and then so I typed all that, I run it, and lo and behold, right, calculator pops up here. So awesome, right? We can get code execution based on this DCOM. But one thing that you should sort of ask yourself if you're curious, so this is the arguments to exec shell command. Like what question would pop up in your mind, asking the group here, based on these arguments here? What question would come up?
Well, my first question is can you run this as a non-administrator?
Yeah, that's an awesome question. So check. Okay, let's try that out, right? So let's see if I have it over here. Okay, so this is a non-administrator. I hit it and I get an error, and the error here is 702E4. And if you were to Google this, it says it's an error based on not having the right privileges. So yeah, unfortunately, according to my experimentation, running this particular command, I'm running it as administrator. And so that was a requirement so far of this command. So that's a really good question. But my question that I have for the group though is more about the arguments here for this particular method. Like what stands out to you?
I don't know if am I allowed to talk and answer? Is that cool?
Yeah, cool. Yeah.
All right, cool.
Please.
So you got your 2 null arguments, so I don't know what those are for.
Good. Yeah. So that's a good question. But okay. So that kind of gets those are the types of questions I would ask, right? I would ask, what are these nulls, and then what is this 7? So here, let me get my freaking web browser working here. So the way to answer that question, right, is I would go to MSDN and actually look up that particular method, right? And according to the method, check it out, right? The arguments are the command, which is calc, and then the directory parameters, and then the Windows state. So those are the parameters. So for directory and the parameters, we gave it null, and then 7 is for the Windows state. What Windows state is a parameter for things such as, do you want it to appear? Do you want it to get focused? Do you want it to minimize? That's what that is. But what doesn't make sense for me is that number 7, right? So for me, being a curious person, I was like, okay, what if I change it to 1? Well, it still works. I get a pop-up here for another calc window, right? And I tried it for a few other values. So I'm not really understanding, what its purpose is or if it's actually even doing anything. So, but according to the examples, they just use 7. So, I'm just going to keep with 7. But anywho, that was just for, a curiosity, right? That us as being interested in technology, we should ask those kind of questions. So another thing that we should try to learn from this is that, what are the artifacts of running calculator in this manner, right? So I'm going to bring up the SysIntern tools process explorer, excuse me. And the interesting thing about here, if we look at the parent-child process behavior of calc, it's spawning under MMC, which is how we did it, right? We use MMC to spawn calc. So that is what it looks like if a red teamer would use this particular technique. So for those who are not familiar with, parent-child relationships with processes, let's just run something like Notepad. So we ran Notepad. What does that look like, right? What does a default execution of that application look like? When you do that, when you run something just from the start button, right? It normally is a child process of Explorer. So the fact that you have something running under MMC, that could be an indicator, if that's not expected behavior in your environment, that something is amok. So, after this, right? So I tested it, I got it to run on my own system. The next goal would be to get it to running on another system, right? That's what lateral movement is. So the machine I wanted to get to run on is this other Windows machine here. Let me fix this here. Windows 7 tab. Okay, cool. Here, and the IP address of this machine, IP configure, is 172.16.166.173, right? So let's put it here, 16.166.173. So I'm trying to create an instance of it, and unfortunately I get an error. So this is the error I'm getting. And if you were to Google this, it has to do with access permissions. So there's some permissions issues with actually using this technique for lateral movement. Unfortunately, before this demo, I was not able to troubleshoot it and get it to work, right? And here, just to show, what's sort of behind the mirror, right? I've tried a lot of stuff here with different settings, and I got a lot of freaking errors. And this sort of just shows you, to get these kind of things to work, right? When you're experimenting with this kind of stuff, a lot of times things don't go right, and it's a lot of tinkering and trial and error. But hopefully I'll be able to figure out how to get this working in the future. And it's just some permission issues with DCOM. Another thing I wanted to share with DCOM, the configuration for it, interesting enough, is called dcom.cnfg, right? So let's pull this up, CNFG. And if we go here to my computers and properties, right? These are like the different permissions. It shows authentication levels, personation levels, default protocols, and different comm securities with access permissions and activation permissions. So I'm hoping to muck up with some of this stuff, and some combination of it will give me the permissions to use this as lateral movement. But according to what I'm seeing and according to what I read, out of the box, right, from a Windows 7 to another Windows 7 box, this does not work. You have to have very specific stuff with DCOM in order for this specific technique to work. And with that, I conclude the demo. I'm going to open it up to the group. Any questions, comments?
Yeah, I have a question, Candy.
Okay, go for it.
So like this type of execution where you're sending shell commands to MMC. I know that there's like MMC in like Windows 10, 2016, 2019. So can you leverage this with more modern operating systems?
Yes, this totally works on modern operating systems. And it's sort of the exact same syntax. And here, let me pull up the blog post for it real quick, right? So in his example, does it show? I did a little bit of research on it, Dave, and this does work on Windows 7. And to make it more interesting, right, all I want to do was to pop calc. But in his blog post, what he ended up doing was encoding a base 64, I think, cradle handler to pop back a beacon shell to Cobalt Strike, right? But anywho, you can do variations of technique to do more interesting stuff. But yeah, this does work on other versions of Windows, more modern versions of Windows, as long as you have the different permissions set properly to allow DCOM to talk to the machines. And as Mikey was saying earlier about a question about what privilege level we have to run it, what I saw was that even on the local machine, it had to be an administrator, a person, right, to launch it. So that's something else to keep in mind.
Interesting.
Yeah.
So Candy.
Yeah. Go for it, Craig.
Oh, sure. Yeah. So as to why it's not working on the remote machine, I'm just curious. You're running as admin on machine A. Is that account administrator on machine B that you're trying to run these commands on? Because without that, it would not work.
So that's a really good question, Craig. So honestly, right now, I don't know what authentication material is being passed from this machine, my client machine, to my server machine. So right now, my two machines are networked as working group, right? So then, for me, I'm curious in terms of, because number one, it doesn't ask for credentials. That's number one. That's kind of weird, because when I interact with SMB type of services, for instance, if I do dir $boss, wait, let me see what machine I'm in. Okay, let's jump to the other VM here. Okay, if I go, okay, if you do net use right here, you see on this machine, I've already mapped the admin share from my other target machine, right? So that's number one. So if I do dir boss PC $C $, right? I have SMB access. There's SMB credentials, at least on this terminal window, right? And the dir command that works. But when I do this through PowerShell, I don't know what kind of number one, the authentication type, right? Is it obviously, I think it's doing one of the net log ons, right? So that's number one. I think it's doing one of the net log on authentication types. And then number two is that what user is it using? Is it using anonymous? Is it using some type of network account? Is it using administrator, like you're saying, right? I don't know, and I'm gonna have to troubleshoot, or if others are interested, I can give this material and hopefully we can sort of play around together and solve it together. But that could definitely be one of the problems, Craig, and that's one of the things I'm sort of trying to track down. Oh, and because you asked that question, let me just pull this up really quick as well then. We're DCOM CNFG. This, according to one of the sort of Stack Overflow answers that I got for possible solutions here, right? They told me to add all of these accounts, right? So check it out. Everyone, network administrators, right? Guest, interactive, and I give them all the permissions. Still, this thing will not go, right? Again, right here, right? There's a difference between, what's the difference between launch and activation, right? And then what's the difference between just access? And then besides these defaults, how does limits work? What does limits mean, right? Again, there's like so many different factors that go into making the decision, the access control decisions. Like, does this person have access? So that's basically the stuff I have to play around with to hopefully get it to work. So yeah.
Well, it's very cool, Candy. Just me being kind of new to all of this, this sort of seems like a living off the land kind of technique, where
yes,
you're not having to bring in, you don't have to bring in a shell. You don't have to bring in a tool to try to do more interesting activities as a red teamer. You're more, or in a CTF, you're more using what's already provided to you in the OS to try to get some level of execution. Is that something that I can kind of take away from this? Like,
that's totally correct, Dave. And I think that's going to be a huge theme as myself and others in our groups share more of these lateral movement techniques. The majority of them are just living off the land type of techniques, and there's multiple reasons for that. So number one is that's what works, right? We're leveraging pre-existing functionality within these systems that allow us these capabilities. So that's a part of it. But then the other part of it that we sort of have to be mindful of is that in my example, all I'm doing is popping calc. But if I want to do something more interesting, say run Meterpreter or run a beacon.exe, in those cases, then I would have to drop those malware on the systems, right? So then what does it become? It become a combination of living off the land techniques, of using something that's already there. Then you also have a malware aspect where you're executing your binary. And then, if we dig a little deeper there, right? The examples I gave was you're dropping something to disk. But then there are other living off the land techniques where you're pulling sort of the malware component from a web server directly into your memory. So there are those kind of techniques too that are currently now very popular with red teams. So, that's a really good question. And, my explanation sort of touches on sort of all the aspects that you have to be aware of. So you understand, what's necessary for red teams to do their operations. And then from our perspective as defenders, right? How can we lock down, or how we can gain visibilities for some of these techniques and hopefully mitigate them and detect them and prevent them. So good question.
Yeah, very cool.
Yeah, so with that, I'm going to, let me see here.
Candy, this is Jay. A couple of questions
Definitely.
that maybe are more basic. In terms of archiving all of this information, it would be nice if we could, in addition to the videos, it might be great if we could have like sources, or like, I don't know, maybe like a wiki that would say, in this video, these things are presented and these are the links and references, so that you could easily find it. And it'd be a little more Googleable than just raw video. And the other question I had was regarding your Windows VMs. Is there, do we have access to a number of different Windows environments, and can those be shared?
Unfortunately, no. So you're going to have your own license. So that's number one. And for most people, that's cost prohibitive. Other techniques that I've used and other people have used is to use the trial versions. So all Windows ISOs, you can use them for like 30 to 90 days for the trial period. And I've done this in the past, where then I'll do the trial and I'll reset it. So that's one option. And then the other option is that Microsoft has these specialized developer VMs that are very similar to the trial VMs as well. And they work in a very similar fashion. So yeah, unfortunately in the Windows world, there's no widely acceptable sharing mechanisms. In terms of reference material, we're going to share all of our references, all of our YouTube videos linked to all of the reference material. The idea of having a GitHub that has all the references, that was something I had in mind, and it's probably something I'm definitely going to do. So yeah, I think, after this, I'll collect all of the different references and the links to all the different information and just throw it to a GitHub, so that way it's easily referenced. So cool.
Yeah, that'd be great. Thanks.
Yeah, definitely. So with that concludes my demo.